Graph the function. Determine the domain and range. We have f of x equals 3 times the square root of x. How am I going to determine the domain and range of this function? Chloe is here with her latest tips and tricks. She wants you to know when your function is in the form f of x equals a to the nth root of the quantity x minus h plus k. A, if it's negative, it reflects across the x-axis. If you take the absolute value of a and it's greater than 1, it will stretch away from the x-axis. If the absolute value of a is less than 1, it will compress closer to the x-axis. If h is negative, it will translate left. If it is positive, it will translate right. If k is negative, it will translate down. And if k is positive, it will translate up. Now that we have Chloe's tips and tricks, we can go ahead and graph this function and determine its domain and range. Now, when I'm looking at this problem, I always like to look at the parent function first. Now, the parent function is just getting rid of the a, getting rid of the h, and getting rid of the k. What would you have left? Well, in our problem, we don't have an h and we don't have a k, but I do have that a. So if I get rid of the a, this will be my parent function. So I labeled this one g of x equals the square root of x. Remember, the parent function is just what it is before you have the a, the h, and the k. That's before anything gets flipped, compressed, stretched, translated up, down, left, or right. So when I am graphing g of x equals the square root of x, I still don't even know what that looks like. So I'm going to go ahead and make an xy chart where I pick values of my x, plug them into my g of x, and I will get y values. So when I plug in 0, I end up getting 0. When I plug in x equals 1, I get 1. When I plug in x equals 2, I get approximately 1.4. When I plug in x equals 3, I get 1.7. Now, the point of this was to show you what the parent function looks like, because anytime there is an a, an h, or a k anywhere in the problem, it's just going to alter the parent function. So it helps to see what the parent function looks like originally. So first of all, I'll graph 0, 0. Then I'll graph 1, 1. Then I'll graph 2, 1, 4. Then I'll graph 3, 1, 7. Now, the more x values you try, the more exact your graph will look. But you can see this is what g of x equals the square root of x, or the parent function, looks like. Now, on this problem, we have some additional things we have to find. So first of all, I am going to go ahead and make an xy chart to get some points that are going to be on my graph. I'm going to go ahead and try the points 0, 1, 2, and 3. Again, the more points you try, the more exact your graph will look. So if I plug in 0 for x, I get 3 times the square root of x, or 0, I get 0. When I plug in 1 for x, I get 3. When I plug in 2 for x, I get 4.2 as my y. When I plug in 3 for x, I get 5.2 as my y. Now I can go ahead and graph those points as well. So you can see I have 0, 0 graphed. I have 1, 3, 2, 4.2, and 3, 5.2. Then I could draw my line through there, and this top one is my f of x. So you can see what has happened is that something happened with that 3 in front. So let's go ahead and look at all of these different things. I do have my function in the form a to the nth root of the square root of the quantity x minus h plus k. And in my problem, I only have an a. So my a is equal to 3. That's what's on the outside. So since I take the absolute value of 3, and 3 is greater than 1, I am stretching it away from the x-axis. Notice that I took this bottom line and stretched it up. That's what I mean by stretching it away from the x-axis. Now my h, I didn't have an h, and I didn't have a k, so nothing happened with translating it left, right, up, or down. Then I can come over here to my graph. I can get rid of the original one, my parent function, because we didn't really need that, but it's nice to compare the two. And then I can get rid of the dots and the point, and that would be my final answer for the graph. Now I have to find the domain and the range. Now the domain has to deal with the x values. So as I go left on my x-axis, my function gets closer and closer to what x value? It gets closer and closer to 0. It actually has a point at 0, 0. Therefore, the domain is bracket 0, comma, and then as it goes right on the x-axis, my function keeps going to the right, which is infinity. Now with the range, we're talking about the y values. So as I go down the y-axis, my function is getting closer and closer to what y value? 0. As it goes up the y-axis, my function is getting closer and closer to what y value? Positive infinity. Since 0 is included, we do have a bracket there, 0, comma, infinity. So my domain and range are both 0, comma, infinity.